Okay, so solving systems by graphing. So we've already graphed lines and inequalities. We're putting it together today. So you're going to have two equations or two inequalities that you're going to graph. So we're talking about system of equations. Is that hard to see in pencil? No? So let's just do a little example of a system just to kind of show you what it looks like. Okay, so it's just two equations that are now together. So instead of like a solution being the solution to one equation, it has to be the solution to both equations. So right now we're just going to do two equations with two variables, but we will get to where we have x, y, and z. Okay, so we'll do three variables. I don't think that's still actually Friday. It's Friday. I haven't finished my calendar up there yet. Okay, so a couple things. There are three types of systems. Three types of systems. So I'm going to do three little x, y coordinate planes. So we'll look at what the picture looks like and then what the words are. You'll have to remember what these are. So the first one, just make any two lines that cross at one point. Doesn't matter where that point is, just a general picture. Okay, so this type of system would have one solution. That one solution, of course, is just where they cross at. And this is called an independent system and consistent. Independent and consistent. Independent just because the lines are like their own independent line, whereas the one we do in a second, dependent, you're going to see that they're the same line. And consistent just means, yes, it has a solution. Okay, on the second one, I'm going to draw one line in purple, and then over it, because they're the exact same line, I'm just going to draw another line. So you can see that it is two lines there. So the first one here crossed at one point, so it had one solution. How many times do these cross? Infinite, yeah. So instead of all real numbers, though, because they're going to ask you how many solutions, so we're going to say infinite solutions, or infinite number of solutions. So infinite solutions, and this is your dependent system. And we also call this consistent, because it does have solutions, and that's all that it's saying for consistent, that there are solutions, whether it's one or infinite. Okay, so we have one solution, infinite solutions. What do you think this one's going to be? No solution. So what kind of lines do you think I'm going to have? Parallel. Perfect, parallel. So parallel is no solution. And the only word we use for that is inconsistent. Okay, if you want underneath that, let's go back to each one and we'll just describe the equation. So for this one, the equation here, mainly we're just looking for different slopes. Okay, they could both be positive, they could be one positive, one negative, it doesn't matter. They just need to be different because then they're going to cross in one place. And that's independent. Your dependent system is the exact same equation. So same slope, same y-intercept. I'm just going to say exact same equation. And then parallel lines have what kind of slope? Yeah, same slope. But of course here there has to be different y-intercepts. That way they're not the exact same line. Okay, then we're going to go over to your graphing. So I'll get out the tape and glue in just a little bit. We're not going to do all of these because really you guys don't need a ton of practice graphing, but there are some specific ones I want to look at with you. So let's just, I want to just start at number 1. So find your number 1. Okay, so when you're doing these, I would recommend numbering the equations, and then that way when you're doing your work over here, I can easily see which equation is which. Okay, so I'm just going to label them 1 and 2. What form do I always want these in? Slope-intercept form. Y equals mx plus b. Okay, so that's the first thing that you're going to do. So number 1, I'm going to go ahead and change the order here. That way I can graph it. So y equals negative x plus 3. And I'm going to go ahead and graph equation number 1. So start at positive 3 on the y-axis. What's our slope here? Negative 1. So down 1 over 1. Make sure you're just careful about your slope because hopefully they cross somewhere and you can easily see where they cross. And then I'm going to put a little 1 on that line so I know which one is which. Okay, number 2. We need to get y by itself. What would you do first on number 2? Good. Subtract the 6x. So 2y equals negative 6x plus 2. Divide everything by 2. Be careful here. So y equals negative 3x plus 1. And I'm going to box out once I'm done. I would recommend dividing the 2 on each one like this. Some of you are doing the big division sign of the 2, and that's fine, but then you're missing one or the other, usually the y-intercept. Okay, and so there's my equation number 2, so I'm going to graph that. So positive 1, down 3 over 1. So the solution is where they cross at, which hopefully you can see on your paper, negative 1, 4. So I want to write the actual solution. What kind of system is this? When it has one solution, what kind is it? Look back at your table. Independent and consistent, right? Not horrible, right? I know sometimes you get tired of graphing. But today's only graphic day, so that's good. We're going to skip number 2. We're going to go to number 3. So it's probably on the next page so that when you fold it in your book, you can see everything. Is everyone ready for number 3? Anyone still on the first one? Okay. Number 3. So we've got equation 1 and equation 2. So how would you get y by itself on this one? What do you have to do? Divide everything by 5. So y equals, what's the slope on that? 1/5, good. 1/5 x minus 2. Okay, I'm going to go ahead and graph it. I like to do everything all at once. So minus 2 and up 1 over 5. Okay, the second equation. To get y by itself, I'm going to add over the 3 first. So 5y equals x plus 3. And divide everything by 5. So y equals 1/5 x plus 3/5. So even though we haven't graphed it yet, what do you notice about the lines?
Same slope.
Same slope, different y-intercept. So what does that mean?
Solution.
Right, it's going to be parallel lines. So start at 3/5. That doesn't have to be perfect, just in between 0 and 1 is fine. 1/5. So we'll say no solution. And that's inconsistent. All right, are you guys good with graphing? You're all good with graphing lines. All right, so let's do some inequality ones. Let's go over to number 5. And mine's going to be number 1. Sorry. Number 5 on yours. Okay, so just, you don't have to write this down, but just to kind of review, you want to make sure everything's in slope-intercept form. Okay, so y equals mx plus b, except there won't be the equal sign. It'll be greater than, less than. So we're going to do one equality and shade lightly, and then we're going to do the other one and shade lightly, because we're going to have areas that cross. We want to make sure that we can see everything. Okay, so don't shade too dark. I would recommend using either a pencil, or as some people last class were using different colored highlighters so they can still see. Okay, so same process as before though. Let's label or number our equations 1 and 2. And let's get y by itself. So number 1. So I'm going to subtract the x over first. Negative 2y is greater than or equal to negative x minus 2. How would you solve for y? I think I hear it. Divide by negative 2. But what happens when you do that? Flip the sign. Don't forget that, or your whole answer will be incorrect. So it becomes less than or equal to positive 1/2 x plus 1. So there's our first one. And I'm going to go ahead and graph that. So I start at positive 1 and go up 1 over 2. Is it a dashed or a solid line? Solid, right, because it has the equal sign under it. So there's equation number 1. And then we have to pick which side we want to shade on. So I'm going to use 0, 0 since it's not on the line. So 0 is less than or equal to 1. Is that true or false? True. So if you're still having trouble figuring out the shading, please come see me so we can get that worked out, since all of these you have to shade every single time. So I just shade lightly underneath it. Okay, second inequality. To get y by itself, all we have to do here is subtract the x over. That one's easy for us. So now I start at negative 1. And I go down 1 over 1 in both directions. Also a solid line. I'm going to do 0, 0 again. So 0 less than or equal to -1. That's false. So here's 0, 0. I go to the other side, and I'm shading. And then here's where it starts to become the double shaded area. So then I'm going to darken that. And here you can check your solution here, which is nice. So you can pick any point in the solution area. So I can pick like -2, -5. Plug it into your 2 original inequalities and see if it works. And that way you can see, did I shade the right area or not if you're unsure. Pick any point in this shaded area, or the double shaded area, and it should work in both of these equations. Okay, when you're done with that one, we're going to go to number 7 on your paper. Number 3. So go ahead and get that first one in y equals mx plus b form. Number 7. And graph it and see if you can shade it correctly. Be careful with that negative sign. Remember, it flips your inequality. That'll change your whole thing. So I got y is less than or equal to 4/3 x minus 7/3. Again, you can just estimate where that 7/3 goes. But it should be in between -2 and -3. It should be solid. And shaded below, or I guess I want to say below, this way. If you plug in 0, 0, it's false, so you shade to the other side. Okay, so when you think about this next one, y is less than 2, think about y equals 2. And how would you graph y equals 2? Is it horizontal line or vertical line? Horizontal, right? Goes through the y-axis at +2. So same thing here, except it's going to be a dashed line because there's no equal sign. So at +2 on the y-axis, I go horizontally, and it's going to be dashed. And you don't have to plug 0, 0 in because most of the time people figure out, oh, it's less than. Less than is below 2, which is everything here. You can still plug 0, 0 in. You would just say 0 is less than 2, and that is true, which is also below. So I shade below my purple line, and so then all of this is now the solution set. So I'm going to be checking your equations to make sure those are correct. And then I compare that to your actual line, and then I check your solution area. So there's lots to look at here. The last one we're going to do is number. Trying to see where it is. Oh no, we have 2 more. I'm sorry. We're going to do number 8 and number 10. So go to number 8 if you finish number 7, and go ahead and start it. The only difference is there's 3 lines there. So it just gets a little ugly. But if you finish number 7, go ahead and go to number 8 where you have the 3 lines. and start graphing all three of those and see if you can get the same shaded area as I do. Be careful with that first one because it's X now, not Y. So you should have a vertical line on that one. Careful picking what number. You can't pick 0, 0 on this one, on the second inequality, because 0, 0 is through the line. So you can pick anything else. It doesn't matter as long as it's not on the line. So when I have more than two, what I like to do is as soon as I've done the second one and I see where I have the double shaded, sometimes I actually go and erase this because it just gets to be so much pencil shading that it just gets confusing. So now I see where that double shaded area is. So then I erase this and now I can do my third line and I can see where my final solution area is. So right now this is where I'm at with the two lines. So then I need to do the third line. Get kind of this area in between all three of your lines, the triangle shape. I will say generally if you have 3 lines or 4 lines, it creates some kind of shape because it's called linear programming, which we'll talk about later, but anyway, it creates kind of like some kind of shape. Square, a rectangle, a polygon of some sorts. So if you have some area shaded like over here, you can't have other areas. We'll talk about the specifics whenever we do linear programming. Okay, the last one I want to do with you is number 10. So on number 10, I want you to go ahead and graph that second line. You can try to do the first one if you want. Just gonna wait on a couple people to finish and catch up. So go ahead and graph the second line if you're there. I'm starting with the second line, and then we'll go back to that first one. Okay, so on number 10, you have this absolute value thing. So if you have something like y is less than absolute value of x plus 2, actually let me put an equal sign in there. If I say y equals that, what would my graph look like? What's the shape of an absolute value graph? A V, right, that would be a V. Okay, we can also do inequalities with absolute values, except that what's missing right here? A y, right? So it's not going to be a V shape. This is completely different than if you were graphing an absolute value function. Okay, so this one, we're going to solve this just like we did on our last test. Okay, instead of graphing on a number line, though, we're graphing on a coordinate plane, so we're going to have vertical lines. So, how do I solve an absolute value inequality? Think back like 5 days. What would you do first? There we go. Separate the absolute value into two equations. So you would isolate the absolute value, but it's already done for you. So then I have less than or equal to 3, greater than or equal to negative 3. So solve for x. X is less than or equal to 1. So there's 1 I'm going to graph. And x is greater than or equal to negative 5. So now I have 3 different things to graph. Well, 3 total. 2 to graph from that one. So since I have x, I'm going to go to the x-axis. So at positive 1, I have a solid vertical line. It says x is less than 1. Oh, I never shaded that one. So x is less than 1 is going to be over here. Then I have greater than or equal to negative 5. So a solid line through negative 5. And I shade greater than that. So now I'm this way. So I can see the double shaded area is in between the 2 vertical lines. So I'm actually going to erase what's on the far left and the far right. So I'm able to see my solution set. Again, you don't have to do that. I just think it's easier to see your answer at the end. And I forgot to shade this one. And can I plug in 0, 0 on this line that we did here? Yeah, it's not on it. It's really close to it, but I can still use it. 0 is less than 1/2. That is true. So I'm shading below that one. And I can see that this whole area right here is my triple shaded area. Which is why I took back my statement saying it's not always in a shape. Because this one will keep on going forever and ever and ever this way. Alright, let me pass out your worksheet real quick. I forgot to put it out.